Assalamualaikum warahmatullahi wabarakatuh. I am Lusi Erlina, name 22. I will explain about matrix.
Supporting lecturer, Mrs. Rohmah Indahwati, S.pd, M.pd. What's matrix?
Matrix concept. 1. Matrix definition and notation. A matrix is a set of square of rectangular numbers arranged in rows and columns and placed in common brackets or square brackets and denoted by capital letters. The general form of the matrix is as follows. Information. 1. Matrix A consists of m rows. 2. Matrix A consists of n columns. 3. A11, A12, Amn are elements of matrix A. 4. Matrix A can be written A equals Amn with M is a rows and N is a columns. Matrix order. 1. The order of matrix indicates how many rows and how many columns are in the matrix. If matrix A has m rows and n columns, the order of the matrix A is m times n and written am times n. 2. The number of elements of a matrix is equal to the product of the number of rows and the number of columns from the matrix. So, matrix order are number of rows times number of columns. Matrix type. There are 10 types of matrix, namely as follows. 1. Row matrix is a matrix that only consists of one row or a matrix of order 1 times n with n more than 1. Example. 2. Column matrix is a matrix that only consists of one column or a matrix of order n times 1 with n more than 1. Example. 3. Square matrix is a matrix that has the same number of rows as columns matrix of order n times n, or often called order n. Example. In a square matrix, the elements that lie on the connecting line of element A11 and element Amn are called the main diagonal, while the elements that lie on the line connecting element An1 and element A1n are called side diagonals. The sum of the elements on the main diagonal is called the trace. 4. Triangular matrix. A. The lower triangular matrix is a square matrix in which each element is above the diagonal main are all 0. Example. B. The upper triangular matrix is a square matrix in which each element is below the diagonal main all or 0. Example. 5. Diagonal matrix is a square matrix whose elements are 0 except on main diagonal. Example. 6. Identity matrix is a diagonal matrix whose elements are on the main diagonal is worth 1. Example. 7. Vertical matrix. Vertical matrix is a matrix with more rows than there are columns. Example. 8. Flat matrix. Flat matrix is a matrix with more columns than many lines. Example. 9. Symmetric matrix. Symmetric matrix is a square matrix with the elements rows in I and column in J being the same with the elements row in J and column in I. Example. 10. Zero matrix. Zero matrix is a matrix in which all the elements are zero. Example: algebraic operation on matrix. Matrix addition. 1. If A and B are any two matrices of the same order, the sum of matrix A and B is the matrix obtained by adding each element of matrix A with the corresponding element of matrix B. Matrices of different orders cannot be added. 2. The opposing matrix of matrix A denoted by negative A is the matrix whose elements are opposite negative of the elements of the corresponding matrix A. Properties of matrix addition. 1. A plus B equals B plus A are commutative property. 2. In the bracket A plus B and then plus C equals A plus in the bracket B plus C are associative property. 3. A plus 0 equals 0 plus A equals A, where 0 is the zero matrix. 4. A plus negative A equals 0, where negative A is the opposite or negative of matrix A. Example of addition matrix. Subtraction matrix. If A and B are matrices of the same order, the subtraction of matrix A by matrix B is the matrix obtained by adding matrix A with the opposite matrix B. So A minus B equals A plus negative B. Example: multiplication matrix. 1. Multiplication of real or scalar number with matrix. If A is a matrix and K is a real number, K times A is a new matrix whose elements are obtained by multiplying K by the elements of A. Properties of multiplying real numbers with matrix. Suppose P and Q are real numbers, A and B are matrix of order m times n, then the multiplication of real numbers by matrix fulfills the following properties. 1. In the bracket P plus Q times A equal PA plus QA. 2. P in the brackets A plus B equals PA plus PB. 3. P in the brackets QA equals in the brackets PQ times A. 4. 1 times A equals A. 5. Negative 1 times A equals negative A. Example of multiplication of real or scalar numbers with matrix. Multiplication of two matrices. The multiplication of two matrices is defined that if A is a matrix of order m times n and B is a matrix of order n times p, the product of A times B is matrix C of order m times p. The elements of matrix C in the I2 rows and J2 columns or written C are obtained by multiplying the elements of the I2 rows of matrix A against the elements of the J2 columns of the matrix B, then adding each one. Suppose we know matrix A and B as follows. The product of matrix A and matrix B is example from multiplication of two matrices. Function of matrix in everyday life. Facilitate in making an analysis of an economic problem that contains various variables for use in solving operational research problems. For example, the operational problems of petroleum resource research and so on. For associated with use of linear programming, input-output analysis both in economics, statistics, and in the fields of education, management, chemistry, and other technology fields.
Thank you so much from me, more or less apologize. Wassalamualaikum warahmatullahi wabarakatuh.